Good day, everyone. Me and my group mates will be discussing the approaches in EI and typical intelligence system requirements. There are four types of artificial intelligence: reactive machine, limited memory, theory of mind, and self awareness. The reactive machine is the most basic types of EI systems, are purely reaction and have the ability neither to form memories nor use the past experiences to inform current decisions. The perfect example of this machine is the Deep Blue IBM's chess playing supercomputer. Deep Blue can identify the pieces on a chessboard and know how each move. It can make predictions on what about to move and what is the next move for its opponent. Limited memory. This type of machine can look into the past. For example, self-driving cars. They observe other cars' speed and direction. These observations are added to the self-driving cars pre-programmed and represent to the world, which also include lane markings, traffic lights, and other important elements. It includes when the car decides when to change lanes to avoid off another driver or being hit by a nearby car. But these simple pieces of information about the past are only transient. Theory of mind. This is where we are, struggling to make this concept work. However, we are not there yet. Theory of mind is a concept where the bots will be able to understand human emotions, thoughts, and how to react to them. If the EI empowered machine are ever to mingle with us and to move around us, understanding human behavior is imperative, and then reacting to such behaviors accordingly is the requirement. Self awareness. These machines are the extension of the class third type of EI. It is one step ahead of understanding human emotions. This is the pace where the EI team builds machine with a self-awareness factor program in them. Building self-aware machines seem far-fetched from where we stand today. Here's an instant. When someone is honking from behind, the machine should be able to feel the emotion. That's when they understand how it feels when they honk at someone back.
Good day once again. So there are also other AI approaches, which is the main approaches. So klase-klase man ang AI approaches. So kini amo ni siyang gi-appeal. In main AI approaches, there are machine learning and deep learning. Machine learning is a subfield in artificial intelligence that is usually relies on statistical methods or numerical optimization techniques para ma-derive ang data without clear or detailed nga computer steps. One important characteristic shared by many machine learning models is the use of probability to represent the uncertainty that widely exists in the real-world problem. Our example for machine learning would be Google, Facebook, or Amazon. There are three main types of learning, which is the supervised learning that requires labeled data for training and computational model. Next is the unsupervised learning, or it examines unlabeled data to discover pattern. Next is the reinforcement learning. So kini siya dili mag-required og labeled data kumpara sa supervised learning, but in reinforcement need siya og action-based feedback such as reward or punishment. There are also other tasks that could fall under the umbrella of machine learning, such as anomaly, novelty detection, data generation, visualization, feature learning, and others. Let's move to deep learning. Well, deep learning is a special type of machine learning. So, bali, ang deep learning is subset sa machine learning. In deep learning, it focuses on developing and using a deep neural networks or DNN for machine learning tasks. So, unsa man ang DNN? DNN is a special type of artificial neural network which has multiple layers, also called hidden layers, between the input and the output layers. So, kada isa sa niya ka layer nag-consist of collection of computing units nga gitawag og neurons, which take the input from the previous layer and i-generate ang nonlinear output to the next layer. Deep learning has gained a huge amount of interest in the recent year due to the outstanding performance. Similar to the other machine learning models, deep learning can be utilized to complete tasks in classification, clustering, prediction, and so forth. An example for deep learning would be driverless vehicles, medical research, facial recognition. Moving on, I will discuss to you the typical intelligent system requirements. We should always remember that with every intelligent system solution, there are risks if it is not designed effectively. So, to help avoid these potential pitfalls, we will discuss or show to you the 10 intelligent system requirements. First is the security. In intelligent system, the product must be designed with security in mind. Product and services must secure data and keep out hackers. Example for this is ATM machine. So dapat sa ATM machine, dapat fully secured siya. Second is the reliability. Choose field-proven product that provide high reliability and stability. So for example, mapalit ko sa Lazada or Shopee. First is I will make sure that the product is high quality. Mutan ako na sa ratings. For example also, kita ako mamaligya. I will make sure sa akong customer nga high quality jud ang akong mga gipang baligya so that my customer will be satisfied. Third will be the scalability. Adding smarter device to your current enterprise RTA infrastructure without providing the IT infrastructure for higher traffic load and device management means it is not likely you will benefit fully the intelligent system. Device must be integrated into an architecture and address those issues and provide the needed resources. In scalability, company can increase sale gives increased resourcement or to adapt increased demand. The fourth will be the flexible extension platform. Flexible means capable of bending easily without breaking, and extensible means capable of being extended. Having a single platform across the various tiers of intelligent system architecture gives a business efficiency, consistency, and predictability. Consistency from an edge various controller and gateways and back into data center makes development, integration, and maintenance much simpler.
So another requirements for intelligent system is the integration with enterprise applications and infrastructure. So once the smart device data is being received back at the data center and analyzed, the solution architecture needs to integrate with your current back-end business process management and data visualization tools. If the analysis tools for collecting of data is not part of your are not part of your current business processes, then there are new tools from independent software vendors might be needed to improve your business efficiency. So for example, if your data feedback loop might require tools for transformation from raw machine data format, as well as the additional tools to um, automate and analyze output easily so that it will be easier for the users to use it. Another requirement is the system and device management. Being able to manage and maintain system and devices is critical to maintaining stability, reliability, and security of a system. So the architecture should provide repair, replacement, and authorization for a complete solution that includes devices, concentration, getaway devices, and data center. Technology that minimize network costs, since network or connection are the most significant cost element of any intelligent system solution. An intelligent system solution needs to come back in, enter into and come back from lower power modes, and it must also includes low cost connection technology via cloud, internet, Wi-Fi, cellular, and even enterprise local area network connections. Older embedded devices typically responds only when pulled, but intelligent system devices report data asynchronously that leads to a significant increase in traffic. Many devices can store data for later's analysis when traffics are too heavy for transmission. Certification is also one of the requirements for intelligent system. Since you need to choose a solution that is already have a ISB certification or independent software vendor certifications that are complied or agreed with a appropriate local, national, financial, and government, and also regulatory agencies. Stable technology product life cycle. Mature testing product with a record of reliability and long-term product can support reduce the cost and complexity of maintaining a solution that is being deployed in the field. So the last requirements for intelligent system is the maintainability. Older embedded devices often have a build it and forget it mentality. An intelligent system are dynamics and perform best especially when properly maintained. So devices must be updated, patch over fixes, and security improvements, and have a new features, and also have a functionality that is needed throughout the service life cycle. An intelligent system design automate as much as of the update process as possible. So that's all for our topic.